Okay, this is the P3 paper from October 2022. It's question number 7. That's the entire question. And we can see this is a functions and graphs question. In particular, looking at modulus functions. We're going to be doing some transformations. We're going to be solving some modular equations. But let's just have a look at it. Fairly standard, this first part, that they give me a graph that's already been drawn, and then what they want me to explain is what's the vertex there and where does it hit the y-axis. The second part asks where it hits the x-axis in there, and we'll do a little bit of work on that. But what I like to do with these is to actually basically sketch that out as though they hadn't given me any information at all, and then that'll pick up the values that I need and also give me some more information for later on in the question. So what I'm going to do, what I've already done, is to draw out a set of axes there. Notice they give me some bits and pieces to draw, and that's for later on in the question. But just to get started here, if we're doing it, just quickly sketch out a set of axes, and then I'm trying to draw the graph of y equals, we're ending up with y equals 5 minus modulus 3x minus 22. I'm going to build that up. So if I'm going to build that up, then first thing I'm going to do is draw the graph of y equals 3x minus 22. So this is the graph y equals 3x minus 22. I know that's hitting down here at minus 2. I know it's got a positive gradient, which means it's going that way. And if I need to work out that particular point there, 3x minus 22 equals 0 gives me x working out to be equal to 22 over 3. Okay, so that's the start off point. Once I've got that, then I actually want to work out what the modulus of 3x minus 22 looks like. So the modulus of 3x minus 22 then would be a reflection. That value there is 22, and quickly using the magic of the iPad, then we get rid of that line there, and we're not interested in minus 22. I'm going to leave it there just because I know what's coming up next. The next thing to do then is to do the minus of 3x minus 22, which now means that this graph is just going to be reflected down here about the x-axis. So actually now I'm getting rid of the top part. So now I'm not interested in that bit up there. I just use the iPad skills to get rid of those. And that's minus the modulus of 3x minus 22, and then the actual graph that I want is 5 minus the modulus of 3x minus 22, which means that this whole graph is going to move up by 5 units. That's going to move up by 5 units, so the new value there is going to be minus 17. That's going to move up by 5 units, so it won't be hitting the axis anymore. Let's just do that. If we do that with this line here and move it up by 5 units, just roughly, because I'm not going to be using this graph anyway, but having moved that up by 5 units, then we're now saying this is at minus 17, not minus 22, and we can now say that the point here, the x value hasn't changed, so it's still 22 over 3, but the y value, instead of being 0 now, as we said, has moved up by 5 units. Let's just make sure my handwriting looks okay on that. So 22 over 3, 5. So in answer to the question then, the vertex is equal to 22 over 3, 5, and y-intercept is at 0, minus 17. Now it's only worth 2 marks, so we only need our answer. I've done all of that working out, and you might think, well, why did you do so much working out only for 2 marks there? But what I'm also going to do is, because of the knowledge I've just gained from that, I'm now interested in what these two lines actually are. What is the equation of this line and what is the equation of this line? Well, if we look at the left-hand one first of all, y is equal to, I know it's got a gradient of 3, I know it has an intercept of minus 17, so that graph is, that line there, I'm talking about this particular line, or this part of a line, is part of the line y equals 3x minus 17, and if I'm looking over at the other side, this has got a gradient of minus 3 this time. We know that because it's a reflection. And if I'd carried that on all the way up there, because it was at 22 originally, and then the whole thing moved up by 5, this is now minus 3x plus 27. Now that's going to help me with later on parts of the question there. So I'm going to put those two bits in there and just remind myself of that for later. Okay, so what are we doing now? Part B says, can we find the x coordinates of the intersection with this and the x-axis? So I'll do this part B down here. Is it B or? Because they're 1 and 2, aren't they? Yeah, part 1 and part 2 are here. Just make it clear to the examiner. So part B then, I'm now trying to find this point, make that a little bit smaller, but this point and this point, which is where the modular graph is going to hit the x-axis, so that's when it's equal to 0. So I can say 5 minus 3x minus 22, when is that equal to 0? And 5 minus minus, so in other words 5 plus 3x minus 22, where is that equal to 0? So that's the two possibilities for what we might be getting in here. If 3x minus 22 works out to be a positive value, then it's just 5 minus it. And if it works out to be a negative value, we're taking the modulus of it, so we're taking the negative of the negative there. Hopefully that makes sense to you. As we go through then to solve those, I'm going to get two values for my answer, so I'm going to get 5 minus 3x plus 22 equals 0, which is going to give me minus 3x is equal to minus 27, which is going to give me x equals 9. That's that one there, because that's the negative gradient, so that value there is 9 naught now. 9 naught. And if we do it with the other one, we're going to get 3x minus 17 equals 0. So we're going to get 3x equals 17, x equals 17 over 3. And obviously 17 over 3 is smaller. That means that that one there is going to be, I'm just going to put the value in there just because I'm not sure for the rest of the sketches when we're doing it exactly how much information I need to put on there. So that's the point 17 over 3. And obviously from what I did previously, we know that this is 22 over 3, 5, and we know that this is down here at minus 17. So I can now translate all that information over. But in terms of answering part B then, we get the point 9 naught and we get the point 17 over 3 naught for the two places where, for part B, that it hits the x-axis. And then part C, now I'd read all the way through to this is why I've done some extra work here, is that this is going to help me with this bit. On diagram 1, sketch the curve C2, which is this quadratic. Identify where it hits the axes. Yeah, that's okay for part C. And then part D, the fact that I've done an extra work will make that a little bit easier in a second. Let's do part C though first of all. Part C says, can we sketch y equals a 9th x squared minus 9. So I know it's a positive quadratic. I know it looks like that. I need to know where it hits the axes. So x equals 0, y is going to be equal to minus 9. and at y equals 0, I'm going to get half x squared minus 9. Sorry, not a half. I'm going to get a ninth x squared minus 9 equals 0, and ninth x squared equals 9. X squared equals 81. So x is going to be equal to plus and minus 9. Right, let's go back and put that on this diagram here. Let's be careful then. So I know that it's going to hit at minus 9 here. I know it's going to hit at minus 9, 0, and 9. All right, so it's actually going to hit at that point there then. So that's one of the things I've got to be careful of when I'm doing this sketch. Taking myself a little bit of time here to say what I should get then is something like this. A negative quadratic, symmetrical about that point there, coming up and hitting up there. Yeah, I'm pretty happy with that. That's okay. So that's y equals a ninth x squared minus 9, and this is minus 9 naught here. This is 9 naught here. And this point now is minus 9. And just making sure that all those things fit in terms of, for example, the fact that minus 9 is above the minus 17 on the axes, etc., etc., when we're looking at it. But no, I'm pretty happy with that. And then part D says, find the coordinates of the points of intersection of the curves C1 and C2. So where did these two graphs meet? Well, that's very handy. They've done that on purpose. That's a clever question, isn't it? One of the points they meet is there, so I don't need to worry about that. It's this point here that I'm going to be interested in doing. So let's just go ahead and do that. So for part D, I can say they meet at 9 naught, and also where a half x squared minus half x squared, I don't know, I keep wanting to write 2, half x squared minus 9, where that's equal to, now we can use the fact that we know what the equations are. This is why I did this bit up here. Okay, we know that the equation of that line is 3x minus 17. So it's where 3x minus, if I'm trying to find that point there, it's where this line, which is 3x minus 17, meets the curve. So that's saved me quite a bit of time now from the fact that I did that previously. So I can now say they meet there, and also where 3x minus 17 equals this. So let's go ahead and work that out. If we're going to do that, so we'll say, I don't know why I keep writing a half. I hope you're noticing these silly mistakes I'm making. And I'm going to leave these mistakes in just because what I'm doing is obviously I'm making the mistake where I'm trying to concentrate on talking to you guys, but I am continually scanning backwards and forwards to just check that I haven't done anything silly like that as I'm going through. So sorry, yeah, we're going to get a ninth x squared equals 3x, and then if we're doing it minus 17, minus 17 plus 9 is going to give me minus 8 there. Multiply everything by 9, so we're going to get x squared equals, 27x minus 72. I hope this is going to work out. Okay, x squared minus 27x plus 72 equals 0. I'd be pretty sure that this works if it factorizes, and it does. I can see that this does actually factorize here, and then the panic I had 10 seconds ago is gone. When we get something like that, then we think, well, that hasn't happened by accident, has it? So I'm going to get x equals 3 and x equals 24. Let's go back and remind ourselves, what was the question? What we're actually trying to do here? We're trying to find the coordinates of the points where they meet. So I want the x and the y value. I've got that solving as a quadratic, and all that is because, and we're not going to worry about it, but if we continued that up there and continued that up there, they will actually meet up there somewhere as well. So it does make sense that I get two values, but I can use the fact that I've done all my work with my graph to say, yeah, we're only interested in this value between the range of things that we've got here. So not in range. for this one, let's just get rid of the arrow, let's just do it. If x is equal to 3, then if x is equal to 3, put that into the either one of the functions. I'm going to do it as the 9th x squared minus 9. 3 squared minus 9, which is 1 minus 9, which is minus 8. Oh, actually, okay, sorry, so point of intersection is 3 minus 8. We'll just go back and check that on the graph. Yeah, that makes sense, doesn't it? Okay, that it would hit there at 3 minus 8. No problem with that at all, as we're actually going through and doing it. Not far away from the minus 9. Okay, hopefully that makes sense.